Hello, everyone. Good morning, good afternoon, good evening, wherever you are in the world. You're very welcome to the webinar. We're going to wait another minute to make sure everyone can log on, and then we'll get started. Okay, listen, I think we're going to get started. My name is Ella McSweeney. Thank you so much for joining us. There has been an overwhelming interest in this webinar. About 1,000 people, if not more, have registered. So it is just great to see. And I think we're in for a really interesting session about how dam removal relates to flood risk management. I am joining you from Ireland, and the reason I'm giving up my time today to be a very small part of this is that no more than anywhere else, we are increasingly seeing the severe impacts of flooding and extreme weather. There are so many positive examples of how removing dams can quickly help some of our most critically endangered species, but we know that the benefits of dam removal go way beyond this by strengthening climate resilience and reducing flood risk. But I think it's fair to say that for many people on the ground, it can be very counterintuitive, the idea that removing a dam can reduce the risk of flooding. So what hopefully we'll do in this session is to hear from the experts about what works and give all of you out there the knowledge and the arguments to be able to move things forward. So I hope you all can sit back and enjoy the next hour. We're going to be hearing from a range of people who will fill your heads with ideas and examples. So first up, we're going to go to Luxembourg to join Claude Shortgen. He is a hydrologist at the National Water Agency of Luxembourg, and he's going to set the stage for this webinar. Claude, go ahead.
Yeah, hi everybody. Greetings from Luxembourg. My name is Claude Shortgen. Like Ella said, I'm a hydrologist from Luxembourg. I'm working for the Water Management Administration, and I will talk today about barrier removal and flood risk management, some experiences from Luxembourg. I will share my screen, and then I will start right on. So I think now you will see my screen in presentation mode. Yes, okay, then let's start. Well, first of all, little context, where are we or where I am located right now. As you may know, Luxembourg is located between Germany, France, and Belgium. The main part of the country is located in the river basin of the Rhine. Small part of Luxembourg is located in the Maas or Meuse river basin. As you can see, we find ourselves at the border of the river basin of these two river basins that I mentioned. At the border means directly that our water bodies are, well, let's say, pretty small in the context of the whole river basin. So small water bodies. As you can see in the table, we have a lot, also in the image of Luxembourg, we have a lot of obstacles in rivers, on rivers, which is a phenomenon that most of you were pretty sure that you all know from your countries. Most of them, I would consider them as small, but small obstacles don't mean that they are easy to remove. We have a few programs in Luxembourg that help us to tackle the problem of the barriers. First of all, the Water Framework Directive, which every European country needs to implement. We have 13 national water bodies that we have declared as national nature reserves from source to mouth in our PNP3 program. We have the Free Flowing River strategy launched at the World Fish Migration Day in 2024. And removing obstacles is a goal of the coalition agreement of the Luxembourgish government. At the Luxembourgish Water Management Agency, there's the Unité des Cours d'eau, so the Department of Water Bodies, who's dealing with the problems of dams, ecological continuity, and flood risk management. which is very cool because all the ecologists, hydrologists, and project manager and construction experts work together under the umbrella of one department, which, in my opinion, helps a lot to tackle these problems and these projects. So I brought an example where we are planning to remove an obstacle and how we deal with flood risk. The obstacle is located on the Seer River in the east of Luxembourg. The Seer River flows into the Moselle River, which is the biggest transparent river in Luxembourg. We share the border with Germany. It's in fact a small obstacle from 0.6 meter high. And we did a project on this specific site in order to get rid of this obstacle. And at the start of every project, in Luxembourg, we do a variance analysis. So we check different options, but one option is always the study of the removal of the dam. So if we can remove, or if there are any specific things that don't work out. The focus on this project is, of course, the continuity, the ecological enhancement of the whole river, but also flooding and the technical feasibility and budget are topics when we start these problems. Just like in our department and a specific project, ecological and engineers, so hydraulic and hydrological engineers are working together to find the best solution. We in Luxembourg, we decided that we will tackle the problems of a potential change in flood risk directly in the beginning of a project, because in our opinion, it contributes to decision-making when you have different variants. It's also a very sensitive issue for potential affected residents. So it's important to know what can be the influence of dam removal on floodings. If we have improvements on flood risks, that can easily increase the acceptance of a measure. So that is clearly a good point. And in the end of the day, we need to have these studies for the approval process. To speed up the projects, we are delivering data to the people are working on specific projects. So we can deliver static values on flood discharges. We can deliver measured water levels, but we are also providing data which help to build up an hydraulic model. For example, digital terrain model, topographic survey, or land cover data. In this specific project, it has been decided to build up a 2D dimensional hydraulic model. This is not always the case. There are other methods that can be used to determine flood risk. Even expert judgment can be a method. It always depends on the specifics on the study area. Well, in this case, due to the fact there were a lot of buildings maybe as potential impacted by the project, it has been decided to make a 2D model, like I said. For this case, there has been additional topographic surveys of the dam and on the bridge, which have been implemented in the hydraulic model. Afterwards, when the different variants have been determined, these also have been implemented into hydraulic model. We did the calculations and could review the results, so the initial scenario and then the impact of the different variants. For example, we look always at the local impact. So what are the differences on the water levels and on the flood zone? As you can see here in red, the flood zone in the left image didn't change much due to the dam removal. We have a few changes in water level. Mainly they are less high, which is a good thing here. You can see this in the image on the right. So the green area means that we have lower water levels. These are two good things in this project. Then we are looking on more regional impacts. We are looking on the water retention. We decided here to have a more simplistic analysis. So we are just looking at the water volume, which has been calculated for three flood scenarios. And as you can see in the table, we have a slight gain in water volume. So there's more space for water, even though it's not big, but hey, it's a positive effect, and that's good. So in conclusion, hydrology and hydraulics always been studied in Luxembourg. In the case of the example that I brought to you, we have no negative but slightly positive impacts. In other cases, other projects, there can be negative impacts, but that don't have to be a major problem. We can always look or find possibilities to compensate them. If not, we have to go to other options. Optimum, of course, positive impacts on flood risk reduction and in removal of the dam. But it always depends on the specific area where the project is located. And in my opinion, it's always good to start flood risk studying at a very early stage of projects. So that was for me. Thank you for your attention.
Thank you, Claude. Thank you. And I just have one very quick question, which you may or may not be able to answer, which is you said it was a sensitive issue for local residents. How do you or do you engage with local communities when proposing and communicating your plans?
That depends on the project. So there can be local meetings where we meet up with the people and explain the project to them. Sometimes we are doing much bigger information meetings where the whole city is invited and can look at the project, ask questions, and then we will talk to them.
Okay, superb. Listen, we'll talk again at the Q&A, but thank you so much for that. Before we go to the next presenter, everyone, we're going to do a very, very quick poll. We want to hear more from everyone who's logging on, and we will use this information for the Q&A a bit later. So we have, I think, 4 questions for you. The first question is really easy. It is from which country you are from. So if you wouldn't mind answering that. We also have a question, what is your level of expertise on this particular topic? From 0 to 5, 5 being very high. Third is barrier removals could decrease the risk of flooding. Do you agree, disagree, or no opinion? And the last one is, do you know real life examples of barrier removal having an impact on risk of flooding? Yes or no? So if you wouldn't mind answering those questions, that would be hugely appreciated. And we'll use the answers at the end of the session. And also, obviously, feel free at the Q&A button there to put in your questions or comments. Okay, we're going to go to France now with Roberto Eppel. Roberto is the founder and director of the European Rivers Network. He is very influential in France and beyond because he initiated one of the first dam removals in France, and his organization is part of the Dam Removal Europe Coalition. Roberto, are you there? There you are, Roberto. Can you take your, unmute yourself?
Sorry. So, do you hear me?
Loud and clear, off you go.
Okay, so, dear friends of Living Rivers, I am delighted to be able to talk to you today about dam removal in the European context. I have both a professional and a passionate personal interest in this topic, which was developed since 1995. I'm chairman and founder of European Rivers Network and have been involved in dam removals since 30 years, initially as a campaigner and activist, later as an NGO networker, mediator and expert, and for the past 10 years also as a founding member of Dam Removal Europe Coalition. First, I would like to introduce you to Dam Removal Europe and its work, and in a second part I discuss the history which a focus on France, pioneer in dam removal. Dam Removal Europe is a movement of river enthusiasts, volunteers, activists, river practitioners, biologists, environmental agencies, and other actors related to the water management and freshwater ecosystem restoration. The whole network joins more than 5,000 individuals, but the motor of this movement is a coalition formed by 7 organizations united by one common goal: restoring free-flowing rivers. Currently, Dam Removal Europe is composed by WWF, the Rivers Trust, the Nature Conservancy, European Rivers Network, Rewilding Europe, and Wetland International. ERN has started in 2016 with the slogan, "The freedom of rivers begin when barriers end." What we do? We take the global approach, think globally and act local. We believe that by connecting the right people and working together, we can restore rivers faster and bring them to life again. Our action model is divided to several activities, mainly the identifying of change makers in the different countries, sharing solutions, generating awareness for the need of removal barriers, and then tracking down existing and removed river barriers, connecting practitioners and river enthusiasts around Europe, and of course helping organizations to find funding for their dam removal projects. Some of the achievements, you can find everything on our website, just the most important points. We are supporting the movement with over 4,000, now 5,000 people, and we recorded over 542 removals. We have a database with over 9,000 barriers which has been removed, and we produced 9 DRE annual reports. As well, we delivered strategic advice to develop and implement the 42 million European Open Rivers program to initiate thousands of dam removals in Europe. And 9 countries have seen their first removal ever through our action. Then we shared knowledge, 12 fully booked international seminars, live webinars, trainings, and in over 20 countries. Then we had annual media and social reach of about 100 million through combined efforts. And then, of course, our DRE website with 84 showcase projects and hundreds of reports and articles, fact sheets, and the DR toolkit. Actually, DRE is running a project focused on scaling barrier removal in southeastern Europe and achieved 109 barriers in the pipeline for removal, 49 ongoing projects in 15 countries, only in southeastern Europe. Yeah? And then 5 countries had their first removal ever, and 10 million euros government funding has been mobilized. If you want to know about DRE, read our reports, visit our website, and or watch the beautiful documentary The Dam Busters. DRE sees itself as the driving force behind the 2-decade-long upscale process. From 2016 to 2020, research and development. Then up to 2030, replication, the example of the cooperation with ORP program and the SCE program as I mentioned. And then of course after 2030, the big shift when dam removal becomes business as usual, driven by the implementation of the new EU nature restoration legislation with the goal to create 20,000 kilometers of additional free-flowing rivers by 2030. The good news for the future is there is no way to achieve this goal without dam removal. However, in order to understand how and why European public policy has developed in favor of river restoration through the creation of ecological continuity, we need to extend the time frame. It's always good to look back and the past to understand where we stand and what are the new paths to take. Above all, which one do not take. This is not new, I agree, but it is still true. So, what is the background? Was there dam removal before DRE? Yes, it started in the 80s and 90s, around the same time as the developments in the USA. The following phases can be distinguished. From the 1980 to 1995, at that time, most of Europe's rivers were in agony, straitened, dammed, polluted and overused. One of the most visible consequences was that salmon and other migratory indicator species either died out completely, for example in the Rhine and Elbe river basins, or were severely threatened. Massive public protests against the ongoing destruction and catastrophic state of the rivers, alerting the public and authorities. Several large dam projects were stopped by unprecedented action by citizens and the large environmental organizations that were just emerging at the time.
I was personally involved in these struggles, in particular in the large successful Loire Vivant campaign against 4 new large dams. The Loire River Basin is the home to Europe's last large wild salmon, the Salmon salar. He became the symbol for a free-flowing river. I remember meeting with North American NGOs in Idaho. During a private excursion, I happened to come across a strange dam on a salmon river. Only half of it was still standing. Local people then explained me that this disused dam had been spontaneously dismantled without any authorization by the local Native American population. Back to Europe, we included dam removal into our Loire Vivant campaign. But dam removal was still absolutely unthinkable in Europe. That is why we first had to unblock thousands of people vines before dam removal became an option. After a 10-year campaign, the vision became a reality.
1996 to 2000. First ever removal of 3 major dams in France, parallel to the removals in the US. Main reason: continuity for migrating fish and outdated dams in poor technical conditions.
Ils sont situés à des endroits stratégiques des axes de migration. Après l'effacement, et dès le premier hiver, on observe en amont du site des reproductions naturelles de saumon.
Then from 2000 to 2010, the EU Parliament votes the Progressive Water Framework Directive. This legislation will be the main driver for future barrier removal policies. A small number of medium-sized and large dams in France and Spain and other countries are being dismantled. 2010 to 2015. France is developing a program for dismantling small dams, the so-called PARS program, including a prioritization methodology and a financing instrument, up to 100% public support for thousands of obstacles. On most rivers, but not everywhere, barrier owners are obliged to create continuity within a reasonable period of time. The program is successful and dam removal is definitively recognized as an efficient measure for achieving good ecological status in accordance with the Water Frame Directive. However, initial opposition against barrier removal is emerging first at the local level and then on the national level. Their political pressure led to a change of the PARS program. This is closely related to the EU subsidies policy for renewable energies. Small dam owners now have the choice between dismantling, heavily subsidized, or installing fish ladders, lightly subsidized, or building a small power plant with fish ladders, heavily subsidized. Parallel to the implementation of the policy to remove small barriers, France has continued with the removal of large dams. Between 2020 and 23, with a view to restoring major migration routes, it carried out the largest removal of European by removing 2 dams, 37 and 20 meters high respectively, opening up the coastal river Seine over 80 kilometers for its historic population of salmon and other large migratory fish.
On n'intéresse pas simplement une petite portion de rivière parce que le premier barrage qui est mis en place est à 14 km de la mer sur un cours d'eau qu'on fait 100 km, de sorte qu'il y a 74 km actuellement qui ne sont pas accessibles, en particulier aux poissons migrateurs. De sorte que l'effacement va permettre de réouvrir ces zones et qu'on va pouvoir travailler à l'ensemble de l'échelle d'un bassin versant.
Le barrage de Vezin, 37 mètres de haut, et sa centrale électrique ont été effacés en 2020, après une longue phase préparatoire, faite de vidange et d'adaptation.
In addition to the complete removal of large dams in particular, solutions involving partial dismantling or the installation of mobile gates that can be opened or closed depending on the season are also being sought. Some examples work well and could be an alternative if complete dismantling is not an option. France's experiences, some of which were experimental in nature, were adopted or inspired several other countries and formed an important basis for the development of DRE strategies from 2016 onwards. One day, every dam and every barrier will come down. It's only a matter of time. Our task is to accelerate the process for as many unused, obsolete, dangerous and highly impactful structures as possible. We should take new aspects in account in our future plans and strategies. In particular, the findings of the social sciences must be incorporated into the dam removal, especially if it's in connection with flood prevention and safety. Additionally, in future we should include not only transverse but also lateral obstacles under the terms of barrier and dam. It is a motivating and forward-looking task. Nature protectors, conservationists, biologists, fishermen, citizens and engineers can work hand in hand, develop know-how and contribute to more free-flowing rivers and for greater biodiversity. With you. Thank you for your attention.
Thank you, Roberto. Are you still there? There you are. And I second the Dam Busters doc is a great watch, so I'd really encourage anyone who hasn't seen it to watch it. It's fantastic. Roberto, 2 quick things. A great quote there. First, we need to unblock people's minds. I just wonder, in your experience, what the key challenges are in securing stakeholder buy-in for dam removal in Europe. I mean, especially from communities who fear that it'll increase flooding risk and flooding in general.
Yeah, I hope I catch the question very well because there was a little bit noise in the connection. Could you please shortly repeat?
Yeah, so I was just saying that you said that first we need to unblock people's minds, and I wonder, in your extensive experience, what the key challenges are to be able to do that and secure stakeholder buy-in for dam removal? I mean, communities are first and foremost potentially very fearful that it'll increase flooding. So, what has been your experience with that, and how have you addressed those concerns?
Yeah, thank you. I understood better. Well, I try to answer with an example. Yes, as you have seen in the video before, we had a large dam removal in the Sediment. And these rivers, of course, they had some function to, as people believed, could stop and stock the floods, you know. So this was, for many people, a problem. They imagined that we will remove the dams and then there will not be more flood protection. So we had really to explain that. And as I said, we had to respect also the social aspects. We had to talk to them and maybe to have a kind of information evenings showing with modelization that there will not be a problem. But most of the time, people, they just afraid. So it's very difficult to take that away. So maybe the good way is to show the positive points. What is the winning side, no? And once you have explained that there is no more danger, but positive side. But the problem is different if you have small dams and small obstacles. Then the discussion is on the way if it will make higher the risk for flood or not. And this is a discussion which is on the way actually in France. But most of the dams we removed was not due to flood protection and risk management, but just for continuity for migratory fishing and sediments.
Thank you. And you might just very, very briefly, Roberto, just mention the Open Rivers project that funds or can partly fund dam removal. I know the next call is open in a few days, February the 16th, I think.
Yeah, this is really a great program. As I mentioned, it's a 42 million program, which is open for everybody who wants to remove dams. There are several criteria, of course, to respect. You can apply through internet on Open Rivers website. We can help you also if you contact us in Dam Removal Europe. We have a kind of help desk, in order to help you. And once the apply has been done, very soon you know if you're accepted or not. There's mostly very important co-financing possible through this Open Rivers program. It's still running for at least 2 or 3 years.
Fantastic. We might put a link, unless there's a link already put into the chat box there for people to take a look at it. Roberto, thank you so much. We'll see you in the Q&A.
Thank you.
We're going to go over to America now, a country obviously with a very long history in dam removal in all shapes and sizes. And the one that many of you may have heard about, which got an awful lot of attention, is the Klamath River Dam Removal Project. If you haven't read about it, it's so worth looking up. It's a brilliant example of the positive benefits across the board of taking dams away. So we have a geomorphologist on board, Kevin Jensen from the company McMillen. He is a project manager of several dam removal projects on the west coast of America. Kevin, the floor is yours.
Thanks so much, Ella. In addition to my duties as a geomorphologist, I'm also a civil engineer, like Ella mentioned, at McMillen. I'm coming to you from Boise, Idaho, not all that far from the Salmon River that Roberto was referring to in his talk. So I'm going to kind of drill down into how barrier removal can reduce flooding. So the focus here is primarily on flooding. And I just need to be able to advance my screen here. Okay. So before launching into how barrier removal can reduce flooding, I'd like to start with some definitions. First, what is flooding? What do we mean by it? Flooding is the unwanted inundation of upland areas, typically occupied by humans and/or human infrastructure. Importantly, flooding in this sense does not include natural activation of floodplains and wild or restored channel systems. That type of floodplain activation is actually a good thing, and we'll see why in a couple minutes. Instead, here we understand flooding to mean that type of inundation that impacts the built environment or impacts public safety or both. And it's this type of flooding that we seek to reduce through barrier removal. But what do we mean by barrier removal? What's a barrier? A barrier is a longitudinal or lateral feature within a river corridor that alters or stops the flow of water. Longitudinal barriers, or sometimes transverse barriers, those are barriers that obstruct the flow of water longitudinally or in the downstream direction. Examples include dams, weirs, and waterfalls. These barriers don't usually prevent water from passing downstream, but they do alter the flow of water as it continues on its path. Lateral barriers are those that obstruct the flow of water laterally or over the banks of a river and into the floodplain. Examples of these barriers include levees, flood walls, and revetments. These are structures that usually keep water out entirely. Okay, so based on these definitions, you might be wondering if certain barriers actually prevent flooding. And I think the answer to that question is yes, some barriers do prevent flooding. For instance, there are dams that have been constructed primarily for flood control. So here's an example on the left from the Los Angeles River in Southern California, where Sepulveda Dam was constructed to detain water and attenuate flood peaks upstream of a highly urbanized environment. And on the right, we have another example from my region in the Pacific Northwest, where Mud Mountain Dam is operated as a flood control facility. These are examples of longitudinal barriers that provide flood protection, but there are also many, many lateral barriers that continue to provide flood protection in developed areas through the use of levees and flood walls. I mention these examples because I want to be clear that some barriers provide flood protection, and their removal may exacerbate flooding risk in the absence of additional infrastructure modifications. So as we continue this talk, please remember that barrier removal should be preceded by a thorough consideration of the existing benefits of each barrier, should there be any. Okay, enough preamble. So what are the primary flood reduction opportunities associated with barrier removal? Well, there are really three primary flood reduction opportunities associated with barrier removal, namely reduction in upstream flooding, floodplain reconnection, and elimination of failure risk. I'd like to talk briefly about the mechanisms of each of these, along with some examples, important considerations, and potential benefits. And we'll start with reduction in upstream flooding. So when longitudinal barriers like dams are installed, they impound water behind them, kind of like this figure. For the fluid mechanics people out there, this results in a decrease in the velocity head and a corresponding increase in the elevation head behind the barrier. That leads to an area upstream of the barrier that experiences higher water levels, all else being equal. So when we take a barrier out, the opposite occurs, right? Water starts flowing freely again, and the elevation head drops down, and the average velocity goes up. And it's this reduction in elevation head upstream of the removed barrier that can lead to reductions in upstream flooding. This is an example from León, Spain, where the San Marcos weir once stood. In the photo at left, we can see the effect of the inundated weir, which creates a hydraulic jump in the flow field. By the way, that hydraulic jump creates a velocity barrier for most aquatic organisms, but that's a topic for a different discussion. In the photo on the right, after the weir was removed, we not only see the disappearance of the hydraulic jump, we also see a significant lowering of the water level. And that's at a flow rate that's roughly twice the flow rate shown in the photo at left. Of course, there are important effects of barrier removal that must be considered in the areas upstream. That includes bank stability. So when water levels are lowered, the bank loses the hydrostatic support of the water column. And in addition, pore water pressures remain high. That can lead to localized bank collapse that can impact property owners. Another consideration is channel degradation. In cases where weirs have been in place for a long time, the channel upstream has likely experienced some level of sediment deposition and channel aggradation. And when a barrier is removed, this area is often oversteepened, and to equilibrate will lead to the mobilization of that impounded material and the associated degradation or incision of the channel. It's not necessarily a bad thing per se, but it can have downstream water quality impacts. And lastly, vegetation impacts upstream of barriers need to be considered prior to removal. In many cases where the water level's lowered after barrier removal, the associated groundwater level upstream gradually lowers as well. This can make it more difficult for riparian vegetation to access water. Okay, let's move on to the second type of flood protection provided by barrier removal, which is floodplain reconnection. This type is focused more on the removal of lateral barriers, like levees and floodwalls, than it is on longitudinal barriers. Here, under the right conditions, when the barrier is removed, the adjacent floodplain will be inundated at high flows, which can lead to both temporary storage and water loss. In terms of storage, as the floodplain's inundated, the water spreads out and slows down. This has the effect of lowering the peak of the hydrograph, effectively lowering the peak of the storm. And in terms of loss, floodplain reconnection may lead to stormwater infiltration into the ground, which further reduces the peak of the hydrograph. A great example of this type of flood protection efforts taken from Johnson Creek, which is a tributary to the Willamette River in Western Oregon in the US. Here, formerly developed rural land was acquired, and the banks of the river were reconfigured to reconnect high flows to a restored floodplain of about 1/4 of a square kilometer in area. That's the little green area shown in the figure on the bottom left that's called out as the East Lents Reach. You'll notice that further downstream, so to the left in the figure, is the town of Milwaukie, Oregon, which has about 20,000 people living there. The impact of this project is shown in the graphs on the right. Essentially, through floodplain reconnection, this project was able to reduce the peak of the 10-year and the 100-year storms by about 50%. This is not insignificant for the people that live downstream in Milwaukie and elsewhere. Of course, for this type of flood reduction to really work, specific conditions need to be met so that we're not doing more harm than good. Specifically, the barrier should probably not be an active flood protection barrier, such as a levee located within an urban corridor. There are plenty of instances of existing levees that are defunct and that no longer protect areas from inundation. These may be good candidates for removal and may lead to downstream flood protection. Another consideration is the proximity of the inundated floodplain to the downstream communities or infrastructure. So if the location where we need protection is too far downstream, the impact of the floodplain reconnection may approach insignificance as a larger and larger watershed contributes water to the river. Okay, the third and final type of flood protection through barrier removal is due to the elimination of failure risk. So in all of the cases I discussed before, flooding is a probabilistic phenomenon. Therefore, flood protection can be understood really as a reduction in flood risk. Here, however, we have the complete elimination of a risk, specifically the flooding risk associated with an uncontrolled release of water impounded behind a longitudinal or lateral barrier. Without the barrier, there's nothing to fail. These figures provide a little more context about this risk. So in the United States, about 65% of historical failure events have occurred at dams that are 65 years old or younger. Meanwhile, about 76% of all dams larger than 50 feet tall, so about 15 meters, are 65 years old or younger. The point here being that the likelihood of failure events into the future seems credible, as does the flooding that may accompany those failures. Mechanisms of failure events include piping failures in earthen embankments through seepage pathways, overtopping failures during floods, or load rejections at hydropower plants, or seiches following landslides, and structural failures during extreme loading conditions such as earthquakes. Okay, last slide. I know it's not the sexiest, but it's important. One of the main considerations when it comes to the elimination of failure risk through barrier removal is related to the existing beneficial uses of the barrier. In the case of lateral barriers, when they fail, they can have devastating consequences. However, they may also protect communities and infrastructure during much more frequent storms. So managers need to weigh the benefits and relative risks associated with keeping or removing those particular barriers. And in the case of dams that could cause significant flooding were they to fail, they too may very well provide societal benefits, including flood protection, water storage, hydropower, and more, such that once again, a holistic approach and thorough weighing of the pros and cons of removal should be conducted. And that's what I've got. Back to you, Ella.
Kevin, that was great. Thank you so much. Really interesting and helpful. A few questions here have just come in. How do you deal with the eroded downstream stretch of river?
After barrier removal, so that's a complex question to answer. In many cases, with barrier removal, the material impounded behind the barrier will make its way downstream and actually grade the channel or build it back up. So there could be localized incision, but on a broad scale, actually dam removal will reestablish that natural sediment transport regime and could help build up an incised channel.
Okay, and finally, when we talk, this is a question that came in, when we talk about open rivers and dam removal, the person asks, I would like to ask if my understanding that we are talking about removal in ecologically important rivers and dams, is that correct? What are your thoughts with regard to, say, hydroelectric projects?
Right. So again, the focus of this discussion was primarily on flood protection. But yeah, let it be known there are absolutely other advantages to the removal of dams and levees, which includes, ecosystem restoration, aquatic habitat health, reconnection, and so forth. It gets kind of complicated once again when we talk about societal benefits related to hydropower. And again, I mean, managers need to weigh the pros and cons of the benefits through ecosystem services, for example, and flood protection, for example, with power production. So
And one
probably
final
not the most straightforward answer, but that's what we
um,
got.
one final question just came in there, and it's one that I think comes up quite a lot, certainly in Ireland. Are there any case studies of covering where the ownership of the dam just isn't known, in which case what happens?
Right. I think that I've heard of instances where the ownership of the dam is not known, but most of those are coming to me from Europe. And that
Mm,
makes sense because a lot of the barriers in Europe have been around a lot longer than the United States itself, right? And so there's this legacy infrastructure that folks on the European continent and elsewhere need to deal with that, we don't deal with as much.
okay, so I might put that to Roberto later. He may have some insights. Thank you so much, Kevin. You're going to be
Thanks,
around
Alan.
shortly for the Q&A. We're going to stay in the US. I'm going to talk now with Lisa Hollingsworth Sagady, who has removed over 100 dams and weirs in her career. She is project manager at American Rivers. Lisa, are you there?
Yes, I'm here. Can you hear me okay?
I can, and I gather you were supposed to be in the field, which would have been fantastic, but the weather is not playing ball. So you are going to tell us a little bit about a site that we're touring virtually.
Correct. And it's behind me on my wallpaper. But hopefully everybody can see this now. Yes, we're doing a virtual tour today because no, the weather has not been good. You'd see a lot of snow out there and not much for the water body. So this is Patton Dam on Chest Creek. Now, creek is an American word for a small stream, smaller than a river. And this dam, this is what it looked like in 2015 when I first started working in that area. And so the point of today's field trip is to see that even small dams, when you remove them, can provide some big reductions in flood risk in a community. So this dam itself was about 4 meters tall and about 20 meters in length. And it had been a public water supply, and that use was retired in 2015. So the dam no longer had a purpose. And let's see, need to go to this. Thank you. Come on. There we go. All right. So moving along, this dam was located actually at the head of a levee. So that was kind of interesting, the situation here. And you'll see this levee actually has some random boulder placement, and it's actually habitat for trout, which is a salmonid species here in the United States. And that was done purposefully just to prove a point that you could add habitat into an area that was levied and it didn't cause any kind of a problem or a rise that would cause a problem with flooding. So we actually did not touch the levied section at all. We just looked at the dam. And behind the dam, of course, we have elevated water, raised the water level about 4 meters. And behind it, we had a wetland that had been drowned and a floodplain that had been disconnected. So as you can see, the dam was deteriorating. This is what it looked like in 2019. The community was just not convinced that they needed to get rid of this dam. It had been their public water supply not since the 1950s. People had an idea that maybe they might put it back in service. That was not possible because the water treatment system was totally obsolete and would have had to been replaced at a cost that the community just could not bear. So I moved downstream 3 miles and removed another dam while this community tried to figure out what was in their best interest. And so they just would not be convinced at all. And Mother Nature helped me out. In 2018, there was a severe thunderstorm that caused the water level to go up over. You see railroad tracks. There's a railway on the far side of this dam. The water went up over those railroad tracks and down into an adjoining neighborhood that had to be evacuated because of flooding. And this was not the first time that they had that type of flooding. And after that flood, the community said, okay, we believe you. Let's get rid of this dam. We realize that the flooding is related to the dam itself. And so here's a comparison, both overhead views, aerial views, and then a picture on the right of dam removal construction, and also the wetland area that was behind the dam that had been inundated. So you can see the changes here. We exposed this wetland. We have lateral connectivity now at this site, and the site was chosen specifically for that opportunity. And then moving on, this is what the wetland looks like now. You know, a lot of people complain if you take out a dam, we'll have a mud hole. And we had that mud hole there for a short period of time. And then we got natural recruitment of vegetation. And we did go in and do some restoration work in this floodplain. So one of the questions that Herman asked me when we talked about this project was, how could we make sure that this is, how could we prove that this actually worked. And okay, so I'm done with my slides. Let me back up here. And the answer to that is that, first of all, we've had 7 storms since that flood in 2018 that have equaled or exceeded the flood flow. And there have been, the stream has not gotten out of its channels. It has not flooded the area that it flooded before. And the next opportunity to prove the benefits would be for the community to do what's called a letter of map revision. So they can actually go in and remap their floodplains and take into account that the flooding does not occur in the area that it used to. And that would be an opportunity for the community to help save some cost on the people that live there. And
Lisa,
finally,
Lisa, one quick thing before your last point, which is, I think it's fair to say that people who live near dams can feel extremely unclear, unsure, and uneasy about the impact of dam removal, and they worry about flooding. And as you say, you found a way, mainly through the fact that there was that, nature struck lucky for you. Was there anything that you said to them? Was there any form of information before that worked?
No. And that was why I moved on and removed another dam in the nearby community, so that they could see that all their fears about the river were not coming true. And I invited people to come down and tour that dam removal during construction and afterwards. And they're like, okay, that's fine. Yeah, we like this. This worked on this dam, but we're still not sure about our own.
Yeah.
And it literally took a flood for them to realize, that I'd been telling them, you're going to get a severe flood. The water's going to go over the railroad. It's going to go into the community adjacent to that. And then when it happened, they said, okay, it's time for the dam to go. And then consequently, these people have become pretty strong supporters. They're very grateful for no longer having flooding. And, the message that I try to carry to other communities is, first of all, I can take you to a place where this has happened, where we've seen this benefit, we've seen the change in flood risk. And the other thing is that it doesn't have to be a large dam causing flood problems. I mean, this was a relatively small dam compared to a lot of areas that get flooding, and just simply removing that small dam and allowing the wetland and the floodplain that were already there to heal, reduce the flood risk. And so now American Rivers is prioritizing these kinds of projects wherever we can find them.
And I suppose as well, within the community, you can recruit them in terms of making videos to show other communities who would have had similar concerns that they have had in the past that it works.
Yes. And not only do I make the videos, but I physically take people around to field trips and show them other dams like theirs that we've removed, and so that they can walk around and see it, and they can talk to the people in the community. And I'm just one person, but if they talk to somebody that actually has lived through that gives them I think a sense of comfort that I'm not just trying to do something I do, but that this is a real experience.
And that wetland there, the photograph, September 2025, is just beautiful, and everyone's heart suddenly appeared when you showed it. What lessons overall were learnt, and I suppose most importantly for everyone who's logged on from countries all over the world, what lessons can you take away from this?
I think the first lesson is it's that people don't understand how water works, and they're afraid of change. And they don't necessarily have a good imagination to figure out what the river is going to look like when the dam comes out. And so I try to provide a lot of photographs of before and after pictures of a dam, just like, I showed you the before picture, and then I've got the after picture here behind me. So that people can see, oh, this is what the outcome is. And then, I can show people the news reports about how bad the flooding was here in July of 2018. And then we can look at the additional, the river data We can look at reports of the flooding, the 7 different times that it's happened since that time. And you can see that these things the flooding just did not happen any longer.
And people are agreeing with you. Someone here saying that's the key point, Lisa. You can show someone a video, but getting folks to the site is the best way for them to understand and appreciate the benefits. A quick question, Lisa. How did you handle the stability of the railroad?
We did one of the things that we makes, and I'm going to go backwards in my slide for just a moment. If you look over on the far side, you can see sort of a little like triangle shaped thing there where the railroad and the dam sort of came together structurally, and we stopped the dam removal at the edge of that structure so that we did not in any way try to undermine or cause a problem with the railroad grade itself. And so leaving that little piece of dam in place on the far side just avoided any kind of problems. We did have to sign some agreements with the railroad company, but of course they're protecting their infrastructure. So we would expect that, and we worked around it and still achieved all of our goals of longitudinal connectivity, lateral connectivity, fish passage, improved recreation access, improved public safety, and reduced flood risk.
Another question, what kind of restoration did you do in the floodplain afterwards to help with the mud hole?
We did very little, actually. We expected, and here's the aerial so that you can see what it looks like. The 2025 picture is a late fall picture, so things were not green any longer. But you can see we have a couple of just sort of natural vernal pools in that area. We did do some live staking along the stream bank itself to make certain that we didn't get an overflow that caused the stream to be way too wide and way too shallow. And we put in some large wood structures, as well as things like nesting boxes for aquatic birds. And but overall, the wetland itself has been essentially self-healing.
Yeah, someone said in the chat box, nature finds a way. We just need to let it find the way, which is very
exactly.
true.
If we remove what doesn't belong, then most of the time Mother Nature can pick up and do the rest of the work itself.
Another question. Are there any examples of removal of consolidation dams, check dams in areas prone to landslides and the effects on slopes?
I do not have any examples of that.
Okay, that's fine. Lisa, is there anything else you want to say before we move on? You're going to come back for the Q&A. I fear I slightly interrupted your final point, but you might have made it already.
Yes. No, the final point is just, each dam has its own context, and it's really important to understand, just as Kevin talked about, take a look at those dams, seriously convey what the opportunities are there, and then come up with designs that are the least amount of engineering invasion, and just remove that dam and allow Mother Nature to do what she does best.
Fantastic. Lisa, thank you. We'll see you in a bit for the Q&A. I'm very grateful. We are now going to Arturo Elosegui, Professor of Ecology at the University of the Basque Country. He specializes in river ecosystem functioning and is especially interested in how it recovers after river restoration actions, such as dam removal. Arturo, are you there?
Yeah, I am.
Take it away.
Thank you. Let me share my screen. Okay, so let me talk about a project where we wanted to remove barriers, dams, and we learned that most of the most difficult barriers were not physical, but were psychological or social. So this is a part of Project Merlin, a large European project, like 22 million euros, 44 institutions, 80 places where we are making different restoration things. And we are implementing a battery of complementary restoration actions from peatland restoration, beaver reintroduction, and so on. In the Basque Country here, near the border of between Spain and France, we are working in River Deva, which is 60 kilometers long. It's a steep river, a very industrial valley, which has a history of very severe pollution, like many rivers in Europe. Now the water quality has improved. Now it's moderate, and but the physical habitat is severely degraded. All floodplains have been developed, as you can see here, with towns, industrial areas, and so on. And we have a myriad of obsolete dams, very old ones. So there we are working as a research partner, the University of the Basque Country, and as what we call implementation partner, the Gipuzkoa Province Council. Our plans was to remove all unused dams in the main channel of the river Deva. That means 10 dams. Well, you can see they are not real dams, they are weirs. They have not capacity to regulate the flow, just elevate the water level. And there are some still active ones used for hydropower and for other uses, but these 10 were long unused. So we wanted to remove all of them. And how do you plan to do that? Well, that depends. Some of the dams have no heritage value at all, so we planned total removal. Whereas in dams with heritage value, our plan was partial removal, like in this proposal here. You can see in the top picture the current dam, and we then there we wanted to open a trench in the middle tier of the dam. Dams and flooding. Kevin has explained it much better than I could. But contrary to common belief, dams, especially urban ones and small dams, increase flooding risk. Only these large dams, which have a large storage capacity, reduce them. And in the Basque Country, we have many flood risk maps, and there are many exercises of modeling what would happen if we remove dams, if we change bridges, and so on. And in general, we see that especially in these urban sections, we can improve a lot the situation for low and for moderate floods. For the big flood, the one that happens once every century, this is not the solution. And we are here in the province of Gipuzkoa, which is one of the provinces in Spain where the economic damage of these floods is larger. So what did we do? First, we met all councils, most city mayors. We contacted all stakeholders in the valley. Hydropower, the water sectors, agriculture, industry, even people who are working to protect the dams. In these stakeholder meetings, we realized that almost everyone thought that dams are good for the people and for the river. So we had to explain them clearly the negative effects of dams, as Kevin did, or maybe not so good, but we used this figure here showing the extent of impacts of the dams. Here you have it, they increase the flooding level, we have more invaders, more mosquitoes, toxic sediments, and so on, so on, so. So eventually, I would say that we managed to convince most people that the dams near their houses were detrimental for them. And in 2022, which was the first year of McMillen, we succeeded at removing 4 out of the 10 dams. So everything seemed to be okay. We were going at a very good pace, but then we hit a double barrier. First, a legal barrier linked to culture, which I will explain now, and second, a psychological barrier. The legal barrier. Well, many of these dams were declared of heritage value by city councils. They said that these were dams associated to ancient mills or factories or whatever, but they declared them of heritage value, but the idea was, even if they are of heritage value, we are going to open them, open a trench or whatever. But the Department of Culture of the Basque government declared that not, these dams are of heritage value, they are of top value, and forbade any actuation on them. Indeed, they intended to protect them as well as the best cathedral in Spain or as the Grot of Altamira. And here you have, when we complained that these dams are creating a flood hazard and so on, they said, okay, you should seek for alternative measures such as dredging, cleaning vegetation, building fish ladders, and you must protect not only the dam, but also the riverscape. So we met these people in the Basque government, and we realized that they were really upset with we environmentalists who despise heritage. So they felt like outraged by all this dam removal movement in Europe. The other barrier is the psychological one, and especially we found this barrier in this town here in Soroluce. It's a town where they have 4 dams downtown. You can see here one of them, and you can see that there is no floodplain. No, it's just in downtown. So when we started to work with them, they opposed dam removal, and their arguments were, no, this is only 2 meters. Salmons can jump 8 meters. The waterfall increases oxygen, and so on, so on, so on. And every time we brought new arguments, new data, showing them that this was a problem, they simply refused to believe us. They said that the maps of flooding risk are pure crap, that the locals, know much better than the foreigners, even if these foreigners are scientists or engineers or whatever. And eventually we realized that they are valuing the landscape effect of this small waterfall, this stagnant water, above everything else. In 2023, things started to get ugly. They started not just to discuss with us, they started with personal attacks. I saw panels with my pictures in downtown. They wrote letters in the local newspaper stating that we were lying. They wrote letters of complaint to the Merlin headquarters and to the university president. That was not fun for us, of course. And there was a heated debate in the town between people pro and against Merlin. So the city council eventually decided to take action. In fact, we knew 2 consecutive measures. Both were in favor of dam removal, but any of them didn't dare to oppose these people against against dam removal. So the second measure in 2023 organized a participatory process with a journalist who knows a lot about rivers, and they gathered all people in town, and they were discussing several days and so on. And finally, they reached an agreement. The city council signed this statement in which they said that dams are bad for the river. This cannot be denied. That these dams increase flooding risk. Some dams are necessary, for instance, these which are used by hydropower. And even some of these dams that may not be important or that are not necessary may be important for some people. But anyway, they said that there are different ways to preserve cultural heritage. Not touching a dam is not necessarily preserving it. And so they agreed to remove 2 out of the 4 dams and to leave the other 2 for the future to see what happens. So in 2025, well, in 2024, the Basque Parliament changed the culture law, and they reverted the power to the city councils to remove the cultural heritage label. They did so, and so we were allowed to remove these dams. We removed 4 additional dams. That totals 8 out of the 10 we initially wanted to remove. And surprisingly to me, there was no major opposition. I expected really to have demonstration and nothing happened. And 2 dams remain for the future. The project is ending next month, but I hope that they will be removed in the near future. Just to finish, the University of the Basque Country started last year to assess the social impact of its research project, and they selected Merlin as a pilot project. So we had a meeting in which they asked me, which is your balance? I thought that it was important for the society and so on. Then the Arantxa Zurunzaga, she's the engineer at the Province Council, and she thought that Merlin changed their approach to river restoration. that they learned the importance of including the local population in decision making. So she was more positive than me. And then the mayor of the town of Soraluce, he said that Merlin was extremely important, that it forced the town of Soraluce to rethink its relationship with the river. The process is still going on, but the outcome will be a more sustainable town. So the most positive among all of us was the mayor who had to live with all these people protesting every day in the door of his office. And so, did we learn anything, or what did we learn? First thing we learned is that still there are many wrong perceptions of the benefits and risks of dams. So outreach is necessary. We also learned that some people will not accept any evidence, and some very clever and very well educated people. So you cannot convince flat Earth believers. We learned that there is an increase in awareness on the importance of natural rivers. And for instance, in Spain, the disastrous flooding in Valencia in 2024 forced many people to think, okay, what's going on? Where am I living? What if the next flood happens here? We know that floods are increasing in frequency and magnitude, and that these low dams or weirs are especially urban ones increase the damage. So let's remove as many as possible to protect the next generation. Thank you.
Thank questions in. You said one thing over another that convinced the people that did change their mind.
Sorry, I didn't hear
Was-
the beginning of the question.
Was there anything of the people who changed their minds? Was there any one thing that was more convincing than another?
It depends on the person. For some people, the ecological benefits of restoring fish habitat was most important. For some others, it was the reduction of flooding risk. For some, the reduction on mosquito populations. And so you need a battery of arguments, and you have to learn how to use them in the right moment with the right person.
We have a question here. What do you do with stored sludge and toxins in the reservoirs? How do you make sure that it doesn't pollute downstream river after dam removal? Is the sludge typically pumped out before the dam removal projects?
Well, I mentioned that this river was in the past extremely polluted. Now, whenever they make analysis of the sediments, they are not so bad, and our rivers are very flashy. So when you remove the dam, the sediments are carried away to the sea or farther. So far we have not seen any impact of these sediments in any. The province council has already removed like 130 dams. Over 1,000 they had in the province, and we have not seen any impact of these sediments.
Okay, we have some more questions here about locals. What evidence did you present to the residents, to the locals? Have any numerical modelling investigations been conducted to demonstrate the specific impact of dam removal?
Well, it changes also what a person considers an evidence. For many people, a modeling is not evidence. For engineers, it should be. And so some of our opponents were engineers, and so they understood very well these modeling exercises on flooding risk and so on. The most important thing for us was to show examples first elsewhere, then examples also which have already been carried out in the Basque Country. And as Ellie mentioned, we also took people to the field and showed them other dams which have been removed.
And how did you deal with false news or fake news that was coming out from the locals? Do you ignore it? Do you try and combat it?
It's complicated. Sometimes they are honest fake news. Some people believe something which is false, so you can spend lots of time talking to this person in private or sending them papers or whatever. Sometimes, they are simply lying. So with these people, there is nothing to do. You just, I think the important point is that to prove them that they are not the center of the world, that most of people in their town do not think like them.
And I mean, as someone is asking the same question, I was just about to ask you, with the removal of the 8 out of 10 dams, have you been able to measure a reduction in flooding for the skeptical people, the people who didn't believe it?
Actually, we had small flooding just before removing one of them. Afterwards, it has been removed, and now we have not had a flood of the same size, but we are expecting it. We have um, a gauging station nearby, and so we'll have this evidence for sure.
And do you have plans to run field trips in these sites for people in other dam-burdened towns, revisiting the past presentation? Seeing is believing, and also learning from people who change their minds is huge.
Whoever who wants to see dams removed, Gipuzkoa is a very good site. There are many examples, large and small. And this year we are removing one even larger than the one shown by Roberto, 42 meters tall.
And the heritage dams, David asking here, how are you defining heritage dams? Is it based on year or by use or combination of both? And
It's
also, sorry, I'm going to interrupt you there and just say, Deborah also asks what they were used for in the past.
Most of them were used for mills. Some were used for steel factories, for smelting factories, and for different purposes. But mostly they are mills and smelting factories. Some of them are obviously of a big cultural interest, because you have the dam, you have the canal, and you have the smelting factory, which still works. Only on Sundays for tourists, but it's intact. Some others, you have just a remnant of the mill dam, which has no canal, no mill, and even the dam has been plastered with concrete recently, so it's much smaller. And one thing that we are learning is that when we open one of these gaps in some of these dams, we discover older dams, wooden ones quite often, behind these dams. And we are, the Department of Culture at the province government, they are always following making an archaeological study of the dam and of the remnants that they find.
I mean, this question of whether heritage trumps climate resilience and mitigates flood risk and all the rest, do you think it's something that will end up in the courts across Europe? And there needs to be some sort of ruling on it, whether heritage is more important than ecosystem and restoration and all the rest?
Sometimes it's a question of legally defined heritage, but often it's not even that. One of the towns in the Basque Country which highest risk of flooding is Tolosa, where the main cause for flooding is a bridge which is less than 1 century, so no heritage value, and it's very poorly designed. So the water agency offered to change the bridge for free, and some locals refused because it was their bridge. So they were emotionally tied to it, but it's not a heritage, it's just like psychology. And we were in a meeting which got quite hot, and eventually we left telling, okay, it's you who is living there, it's not me. If you value this bridge more than your garage, than your car, or than your family, that's up to you.
Yeah. Just finally, Arturo, of the skeptics locally, have any of them come back to you and said, I'm sorry, I got it wrong, I get it now? Or not?
No, not so far. We'll see.
Yeah. Okay. Arturo, thank you so much. You'll be
You're
coming
welcome.
back to us for the Q&A. That was so interesting. Thank you. We're going to go to the lowlands of the Netherlands now. Mark Schiepens. Mark is an ecologist at the Regional Water Authority in Dommel. This water authority is spearheading the restoration of free-flowing rivers in the Netherlands, and they're setting examples. Mark, we are looking forward to hearing more about this. Take it away.
Yes. Well, first, do you see the screen?
Yes, yes, off you go.
Okay. Before I go to our projects, I will tell you something about our water authority, because it's important to know which challenges we face right now in restoring rivers and removing dams. The Water Authority is responsible for managing and improving the water quality and quantity in the streams and rivers located in the central part of the province of North Brabant in the south of the Netherlands. We are responsible for wastewater treatment and for the management and maintenance of the streams. We are also responsible to take measures to improve the chemical and ecological status of our streams. This stems from the responsibility we have to achieve a good ecological status of our streams in accordance with the Water Framework Directive. Central located in our catchment area is the city of Eindhoven, and this area is especially known for its high-tech industries, and the company ASML is the largest employer in our catchment. Now, something about the history. The streams were formed after the last ice age approximately 20,000 years ago. The melting ice eroded the valleys and streams, creating streams on a primarily sandy subsoil. The streams are naturally fed by rain and groundwater. Very deep and old groundwater seeps upwards in the catchment area, primarily in the stream valleys. In the southern part of the river basin, the level landscape is approximately 35 meters above sea level, and in the north, where the Dommel flows into the Meuse, the landscape level is approximately 3 meters above sea level. We call our streams lowland streams on sandy soil. Now, the Dommel Authority was founded in 1863. Our only goal back then was to drain the water as quickly as possible for agricultural purposes and improve the situation for urbanization. This means that streams were canalized and many weirs were built to artificially manage the water level. We have installed approximately 170 weirs that restrict fish migration and the achievement of a good ecological status. Most weirs have a drop between 0.5 and 1.5 meters. The weirs are not big dams, but big enough to prevent fish from migrating. More importantly, they restrict free flow, preventing processes like sedimentation and erosion. As a result, a lot of silt remains in the water system. If we would only install these measures had a major negative impact on the ecology of the streams and stream valleys. Also importantly, groundwater levels have dropped dramatically, and the wet river valleys with their natural rich vegetation and biodiversity have largely disappeared. Now, in 1989, we started with our fish migration program. The goal is to at least have a fish passage or a weir removal at each of the 170 weirs before the year 2027. In this map of our area with in green, the weirs where we have solved a fish migration bottleneck. In red, the weirs where we still have an assignment. We are not going to achieve the goal to be ready before 2027, but we have already come a long way. We have from 1989 till now solved 104 bottlenecks, and we have about 60 weirs where we have yet to solve the fish migration bottleneck. From the 104 fish migration solutions, there are 56 free flow solutions and 48 technical solutions. When we are working on a solution, the first thing we look if we can remove the weir. If that's not possible, then we look for a technical solution. If we would only install technical solutions, then we would not improve the ecological status of our water system. The challenge with removing weirs is that we must combine this with stream and valley restoration. We achieve this by removing weirs from streams in conjunction with stream and valley restoration. When the weirs were built, the streams were also canalized. So we cannot remove the weirs if we not also let meander them again. In the right of the screen, a photo of an example of one of our latest remeandering projects. In this project, we have removed 3 weirs. Now, why don't we always go for a technical solution or go for a free flow solution? Especially in urban areas where there's no room to remeander, the streams are therefore, and therefore we cannot remove a weir. Especially in urban areas, there is no room to remeander the streams, and therefore we cannot remove a weir. In this picture on the left, a weir in the Dommel in an urban area. We have made a vertical slot fish passage and a canoe gutter on the left side of the picture. In urban areas, there's no room to remeander. In some cases, the weir is not a weir but an old watermill, and those in the area of Eindhoven are all projected monuments, and 3 of them are painted by Vincent van Gogh. which makes them a part of our culture. This one is the watermill of coal, and it is still working. You can see that the picture does not quite match the painting. The watermill has been restored after Van Gogh drew it in 1884. The Water Authority was initially established solely to ensure drought conditions. However, with climate change, we are now seeing prolonged droughts combined with increased rainfalls in short periods of time, forcing us to change. Add to this the enormous population growth, and the drinking water supply in our catchment is entirely dependent on groundwater. Farmers also extract significant groundwater for crop irrigation. This causes groundwater levels to decrease, which has a direct impact on the water flow of streams and valleys. The water system is out of balance despite the fact that the Netherlands has a precipitation surplus. The summer of 2018 saw one of the driest years. Due to the drought, there was a lot of drying out and therefore a lot of fish mortality in our streams. The winters of 23 and 24 were years with extremely high rainfall. The rainfall caused a lot of flooding, mainly in rural areas. Especially after the dry summer of 2018 and 2019, we realized that things need to change and that water should be a guiding principle. As a catalyst for this dry period, we, Waterschap de Dommel, have developed a new vision, the water transition, what water wants. It divides the area into three parts, the high peaks, the flanks, and the stream valleys. In the stream valleys, we have set goals to sufficient space to absorb rainfall peaks, a stream valley that does not have a drying effect on the environment. That means water gets more space, streams keep flowing, and the valley is becoming wetter. Now, what will the Water Authority do different to achieve these goals? We have subsidies for blue services where farmers can get compensation for loss of income due to water targets such as water storage, the discontinuation of crop protection products, and measures to increase ground and surface water levels. When we have taken the measure stream valley restoration, we then sell the land with the restriction that it must be managed as nature and that no more fertilizers or pesticides may be applied to the land. For the run stream, I have worked out how we have applied the water transition in practice here. The run is a lowland stream upstream of the city of Eindhoven. The stream has also been canalized in the past, and numerous weirs have been installed. As a result, the ecological quality is poor according to the Water Framework Directive. To improve the water quality, we began removing 2 weirs in 2021. Instead, we re-meandered the stream and created a floodplain. The stream's immediate riparian areas have been removed from agricultural production. Measures have been taken to weather the stream valley by filling in ditches and making the meandering stream very shallow, so it does no longer capture as much groundwater. With these measures, we have an increase in flooding, which we have taken very deliberately. We bought the agricultural land along the stream to develop it for our water purposes. The picture on the left is the canalized stream. Due to the measures taken, groundwater levels have risen significantly, and the water is now above ground level. In the graphic, you see the groundwater levels before and after the project. The photo under the graphic is taken during the execution of the work. In the photo on the right, you see that groundwater no longer seeps directly into the stream, but flows across the ground to the stream. Now, in the background of the photo on the right, you see white buildings. Those are ASML buildings where they manufacture their famous chip machines. And behind them lies the city of Eindhoven. If there's extreme rainfall, build-up areas in Eindhoven can flood. These are situations that occur once every 100 years from our calculations. If that threatens, we can store an additional 460,000 cubic meters of water in this area to prevent flooding in Eindhoven's urban and industrial areas. We build this weir and dike on the left. The weir is always inactive, so it doesn't restrict free flow or restrict fish migration. If the city of Eindhoven is in danger of flooding, we will raise the weir and the run catchment area will automatically fill with water. Here are some results of the project. Now, what challenges do we face? We have subsidies for blue services where farmers can get compensation for loss of income due to water targets, such as the water storage and the discontinuation of crop protection products. It is still entirely voluntary to participate in this, and the compensation does not always outweigh the profits from current crops such as beet, corn, and potatoes. Those vegetants do not go well with wet stream valleys, so there is some resistance among farmers to up-level water and groundwater levels. In the Netherlands, we've always tried to control water. Now we need to make water the guiding principle, something that's not yet in our DNA. Current generations often prefer a water system that is manageable and controllable. This is also where the shifting baseline syndrome comes in. Entire generations, including myself, are no longer accustomed to wet stream valleys. Because we Dutch people have such a long history of fighting against water, we often see the danger of water more than the benefits it brings us. It would be wonderful if the new generations were given a different baseline, where they are once again accustomed to stream valleys being wet, highly biodiverse, and also protect urban areas against flooding. And the good news is that we have some farmers who see opportunities to farm biological and use the wet stream valleys to their advantage. A biological farm has bought 30 hectares of wet stream valleys to use the vegetations in their deep litter cowshed. This was also a project where we moved to weirs and created a wet stream valley and flowing stream. After the project was done, we sold the land to this farmer for a reduced price because the land has restrictions in the use of fertilizers and crop protection. And because wet stream valleys do not have such a high yield and mowing entails higher costs. So the answer to the question, can dam removal prevent flooding? Yes, it can in places where we absolutely don't want floods. In the big part of our stream valleys, we should rise the water level, and that means that it will increase flooding, which is important for our biodiversity and to restore the water balance. And in most cases, it will reduce the risk of flooding in urban areas. That's my presentation. Back to you, Ella.
Mark, thank you. Thank you so much. We see the dangers of water rather than the benefits it brings us. I think that's very, very true. Thank you so much, Mark. We will take a quick look at the poll results, if they can be brought into the screen there. Favos, maybe you could show the results of the poll earlier. So, what is your level of expertise? So kind of in the middle. Barrier removals could decrease the risk of flooding. Vast majority say yes. Do you know real life examples of barriers removal having an impact on risk of flooding? No, the majority no. Okay, so we're going to bring all, thank you all for your responses. We're going to bring all the panelists in. And I'm going to put some of the questions, and I'll put as many as I can that we can get through in the next 10 minutes or so before we wrap. And I will put them randomly to everyone. Panelists, just put your hand up or go ahead and answer them as I ask them. So Peter asks, all the talk has been about dam removal. Are there examples where dam removal has promoted beaver dam building and created unanticipated problems? Kevin.
I actually was just moving the hair out of my eyes and not really raising my hand, but beaver dams can be an issue. On the other hand, they can clearly be an ecological benefit. So it's a little bit of a complicated situation there. I'll kick it to anyone else who wants to augment that.
Anyone else wants to come in? Lisa?
Yes, so we actually build beaver dam analogs in certain cases because we're trying to get water out on the land, and particularly in the arid West and the high Sierra Mountains of California, American River staff is putting in beaver dam analogs because it reduces the risk of wildfire as and it causes invasive species to die out and supports native species because it returns the hydrology to an area that's been altered because of climate change and because of other man-made conditions in the watershed.
Okay, super. And we have a question for you, Mark. When Mark speaks of technical solutions, do those cover migration in both directions?
Yes, they do.
And another question Mark has mentioned about taking land out of agricultural production. How did this play out? How was this funded? And was there any objections? Were there any objections to this by landowners or farmers?
Yes, it's a big puzzle to sort out, to get the land, to get the farmers to work and sell their land to us. And then we we make this project and then we sell the land back to farmers or some landscape organizations.
Can you
But
talk?
it's also we have to buy the land to do the project, because the dam removal is not only dam removal, but it's also remeandering the weir. So you need the whole floodplain, and sometimes some agricultural some farms sell our land, but sometimes we make we give them like subsidies for the higher the higher water levels that we created after we restored the floodplain.
And how do you deal with resistance from landowners or farmers? What kind of things do they say, and what works to convince them?
Well, a good price for their land is a big factor, of course. But sometimes also we try to sell land somewhere else, and then we try to give them other land to work outside of the floodplain. So we have more instruments to convince like farmers to cooperate with us. So mostly but it takes a couple of years, and it also takes and there's not all farmers are willing, but mostly we can with good conversations with the farmer we can sort things out.
Does anyone else want to come in on that particular point? Because obviously Arturo, you spoke about locals in the urban areas, but has anyone got a point to, or anything that you can say with regards to farmers and landowners in particular? Roberto?
You're speaking very fast as a running river, Lisa.
So I apologize.
But
It's an old habit.
I understand. Yeah, of course, you're touching a very important question, which is not only when you're working with farmers, but in generally with people who are in the beginning opposed to any dam removal. I think the most important thing is that you have to take into account these people seriously. You must then give the feeling that you are interested what they are, not just inform. There must be a communication between these people, and this is maybe the basic thing. Most of the time, the people, when they are opposed, they said, "You decided without us, top down," instead of, let's say, the opposite. So psychology is needed. I can't give you an answer, standard answer. Needs a lot of feeling and maybe knowledge of people who knows to deal with social aspects. Not only engineering. Social engineering is as important as the technical engineering. Maybe we should learn to do that.
And Arturo, I'm going to slow down my speech now. Arturo, you spoke about the locals saying, we know best. Who are you to come in and tell us what we've been experiencing and what we look at every day? And so the obvious question then is it important to recruit a local person to be able to be the kind of champion, to understand the issues and be able to communicate?
First thing, obviously, many locals know a lot, and they can give us a lot of clues of information to improve our plans, or sometimes it can be, okay, this we are not going to touch this dam by the moment. But yeah, I think the fact that someone comes from outside to teach you how you poor ignorant in your poor town should behave doesn't sound very good. So it's good to have local contacts. In the Basque Country, it's a small country. We are 2 million. We know each other. So always you can find someone who knows, who it's pro restoring nature, whatever. You can work first with this person and then spread the message little by little.
Lisa, do you want to come in on that at all before I go to the next question?
Absolutely. One of the things that I try to do when I start working in a community is to find out what their history is, especially with respect to the river, the things that people care about. Have there been big events in the community? And then I find someone locally that's trusted. A lot of times I work with an organization that we call conservation districts that's created by the state government and the local governments. And they're the ones that go out and help farmers access subsidies and put in best practices on their land. And they're generally very well respected. And so they go with me to public meetings, and they go with me to meet with individual dam owners. And in some cases, they say, I've been working with Lisa for years. We've done 3 or 4 other projects together. This has all turned out well. You want to go see them? What can I tell you? And because I'm generally not from anywhere near where those people are living and working, and having those local people that are trusted makes a lot of difference. It gives us the credibility that make people be willing to sit down and listen and think about things outside the box.
So it is about listening and then building trust.
Yes.
If I can,
Yeah,
if I can
go
add
ahead.
one point,
Yes,
is that it's also very important to build trust between these researchers and the managers. In our case, it worked very well. We have been collaborating for many years, but quite often I think that there is this gap between the academia and the real world, or the managers. And so this is also a source of many quarrels and of many failed projects.
Super. Okay, next question. Kevin, this might be one for you. How do you assess the impacts on upstream ecology and loss of retained volumes during periods of drought?
Right. So take the question to mean the loss of retained water from a storage reservoir during a drought and upstream impacts associated with that. I'm having a little bit of trouble connecting those dots, but I do imagine downstream impacts potentially. Our water storage reservoirs are often storing irrigation water that can be really in high demand during the summer months. And so, removing a dam that is an active storage reservoir may have downstream impacts in that regard. However, I don't know of many large storage dam removal projects that have taken place where there's still a really excellent active storage component. And in those cases where there were measures, put in place to make sure that that water supply was maintained. Someone mentioned in the chat actually a really good point related to water storage and sediment. The truth is that our storage dams, they do a good job of storing water for any number of purposes, but the truth is most dams are not really managed or outfitted with kind of sustainable sedimentation in mind, right? They tend to fill in and eat into that storage component so that over time, we lose that benefit unless we completely retrofit the system, which can be super costly.
Yes.
So I didn't really get to the upstream impacts, but there certainly could be downstream impacts and considerations.
Okay, we have a question from Abdullah. Is dam removal a viable option for developing countries which use them for power production? Does anyone want to come in on that?
I believe that in all countries, developing and developed, there are dams that are necessary for hydropower or for, as Kevin was telling, for water supply, but that there are many more that are useless, that were built for some purpose some centuries ago, some decades ago, and they are not longer being used. So I don't think here anyone is advocating for the total elimination of all dams. I think the pendulum went to an extreme, at least in Europe, and I believe that in some regions of North America too. And so we are trying to bring it more towards the middle.
Another question here. Sorry for the delay. I'm just reading them as they come in. Thank you so much for everyone, all your questions. Can you share any data clearly showing that weirs don't reduce flooding, or which show that they actually can amplify them? Anyone want to take that up?
I can show modeling exercises, but the Basque Water Agency, which the towns with the dams, the flooding risk, how that would decrease, and also the history of some towns where dams have been reduced or removed after a large flood, and subsequently the damage caused by floods have been reduced, but not technical papers. Maybe Kevin knows some, I don't know.
I don't know of any consolidated data, but each example is a data point, right? And I think that there are plenty of data points out there. I mean, we've talked about several case studies here today. Dam removal, weir removal, particularly in the upstream direction, it's pretty clear. The evidence is pretty clear. It does reduce flooding.
Okay, I think we're going to wrap up now. We're a little bit over time, but thank you so much, everyone, for your contributions. There's a few little announcements I know that the team want to make. So we have, let's have a look here. Dam Removal Europe. So we have a slide, if Favros can put that up there, of the actions over the next couple of months, just to show you all. It is World Fish Migration Day on May the 23rd this year. So you can see there what's next and what's coming up. There is a global dam removal webinar on April the 7th. Sorry, I'm probably going ahead of the slides here. It's organized by the New Dam Removal Global Coalition, and the Zoom link will be put into the chat there. There is a dam removal workshop at Fish Passage Conference on May the 4th to the 8th in the US, organized by American Rivers, McMillen and other partners. And I presume all of those links will be put into the chat so people can follow up on that. But I'm going to say thank you so much, most importantly, to everyone for tuning in. Thank you so much to the panelists. Thank you to the organizers. I hope everyone found it useful. And it's goodbye from me.